Hi students, this is Mr. Yao. In the previous two lessons, we have learned about geometric sequence, the recursive formula, and the explicit formula. In this lesson, we're going to work on some extension questions. First, prior knowledge, let's quickly review the recursive formula and the explicit formula. Here you go. First one, the sequence is given, and in order to find the recursive formula or the explicit formula, we need to find a sub 1, and in this case, r. So a sub 1 is negative 18. The r is going to be the second term divided by the first term. And to confirm, let's also do another one, the third term divided by the second term. And they're all going to give us r as 2. So recursive formula, a sub 1 is negative 18. A sub n equals a sub n minus 1 times 2. And the explicit formula, a sub n is going to be negative 18 times 2 to the n minus 1 power. B, given the explicit formula, find the recursive formula. A sub 1 is negative 12 times 1/2 to the 1 minus 1 power, which is just 0 power. And anything to the 0 power is 1, so it is just negative 12. And also, typically when you have the a times b to the x power, that a, which is right here, that is our a sub 1. So it's a little bit different compared to the arithmetic sequence. You don't have to always plug it in. That number itself is our a sub 1. And then a sub n equals a sub n minus 1 times 1/2. Next, given the recursive formula, is asking to find the explicit formula. First term is given, r is right here, so we can write it right away. A sub n equals 72 times 1/3 to the n minus 1 power. But we have to make sure to put parentheses. If we don't put parentheses, the n minus 1 is just going to be on the 1 instead of on the 1/3. Now let's move on to the examples for this lesson. Example 1. Given geometric sequence r negative 1/5, and you're given a sub 5, which is negative 1 over 125, is asking to find the explicit formula. Well, r is given, so in order to find the explicit formula, we need to find our a sub 1 in order to be able to write the explicit formula. But we're given a sub 5. So in order to find a sub 1, we kind of need to go backwards. So a sub 4, a sub 3, a sub 2, and then we can find a sub 1. A sub 5 currently is negative 1 over 125. Typically, when we actually try to calculate if we know a sub 1, we're going to go forward. So going forward is multiplying by a negative 1/5. Multiplying by a negative 1/5. But that means when we actually go backwards, we can't just multiply by a negative 1/5 anymore. We actually need to divide by a negative 1/5 since we're going backwards. Or dividing by negative 1/5 is the same as times a negative 5. When you actually change the operation, we're going to use the reciprocal, which is negative 5 over 1. So we're going to multiply the negative 1/5 over 125 by a negative 5. That's going to give us a positive 1 over 25. Then we're going to do the same thing times a negative 5, and that is going to be a negative 1/5. Go back again times negative 5, and that's going to be a positive 1. And then go back again times negative 5. That's going to give us a negative 5. So a sub 1 is negative 5. Now we can actually use a sub 1 and r to write the explicit formula. A sub n equals negative 5 times parentheses negative 1 over 5 to the n minus 1 power. That's our explicit formula. So one thing again to be careful, if you actually multiply this way, when you go backwards, you have to divide. And when you have a fraction, you can change it into multiply by the reciprocal. That's example 1. Example 2. You can pause here and try it out. Okay, let's have a look. So this time you are given a sub 6. So let's go backwards. A sub 5, a sub 4, a sub 3, a sub 2, and a sub 1. Going forward is multiplying by 3, which means when we go backwards from 81, we have to divide by 3 now, or times by 1/3. But this time we don't have a fraction, so we can easily just divide by 3. That's going to give us a 27, and then divide by 3 again, we're going to get a 9. Divided by 3 again, it's a 3. Divided by 3 again, it's a 1. Then divided by 3 again, it's a 1/3. So we know a sub 1 is 1/3. So we can actually write a sub n equals 1/3 times 3 to the n minus 1 power. There you go. That's example 2. Moving on, example 3. Given the recursive formula, a sub 1 equals negative 15, a sub n equals a sub n minus 1 times 1/3, find which term is negative 5 over 81. So it's basically asking for a sub what this n is going to be negative 5 over 81. That's basically what the question is asking. It's going to involve some calculator work. So let's actually get a calculator up. There you go. So, let me actually write it in a different place. We need to find a sub n equals negative 5 over 81. Okay, first we got to find the explicit formula. So let's get to it. We know a sub 1, the r is right here, 1/3. So a sub n equals negative 15 times, don't forget the parentheses, 1 over 3 to the n minus 1 power. Okay, here comes the calculator. And the next step is we're going to need to click mode, which typically is the case because we got to try to get fraction answers. This question is giving you as negative 5 over 81. So let me put the calculator here. You're going to click mode and then go down to answers. Oh, for this calculator, as you can see, I don't have that. So in that case, if your calculator doesn't have the option, then change the fraction into a decimal. So I'm actually going to do that first, and then I'll show you with another calculator. I think I can change it here. Let's see. So mode, and then I go down. Oh, there you go. For this one, I can change into fraction. So let's do that. Again, if you can't do it, you are going to need to change the fraction into a decimal, and then you will see later where we're going to find that number. So in this one, I'm going to press enter. I'm going to change it into a fraction. So that's the second step. And the third step, I'm going to press y equals, and I'm going to type the function into the calculator. Let me get it smaller a little bit so we can actually see a bit clearer. Okay, press y equals, and then we're going to type in the explicit formula. Negative 15 times, don't forget the parentheses, then 1 divided by 3, parentheses back, raised to the, instead of n minus 1, it's going to be x minus 1 power. There you go. And then we're going to press second and graph. So this is the process that we have actually done in the exponential unit, lesson unit. And that's where we actually type in, when we press second graph, we're actually going to get a table. There you go. So here's the table. And that leads us to the next step. We're going to find the number in the table, and the x value is going to be the index. So as you can see, the first term is negative 15, and then it's multiplied by 1/3, multiplied by 1/3, and keep going down. So we're going to go down, and as you can see, negative 5 over 81 is when x equals 6. So in that case, we can actually draw a conclusion. N equals 6. So a sub 6 is going to give us negative 5 over 81. There you go. So that is the process. Now you can actually try it, the same process, with example 4. So let's go over it. I'm going to find the explicit formula first. I already did the step 2, so I don't have to change into fraction again. So let's see. I'm going to find the explicit formula for this one. I can see a sub 1. A sub 1 is 8. And from 8 to 4, well, r is going to be the second term divided by the first term, or the third term divided by the second term, which is going to be 1/2. So I can write my explicit formula. A sub n equals 8 times, create the parentheses, 1/2 to the n minus 1 power. Okay, so for this one, I'm going to pretend I actually don't have the fraction option. So I'm actually going to go back. I'm going to change it to auto, which is going to give us a decimal. So I'm going to pretend I actually don't have that. Don't have the fraction option. Okay, but I'm going to do the same thing, except before I actually type the function in there, I'm going to need to change the fraction that I need into a decimal with all the digits. The number that I need is 1 divided by 512. There you go. So I'm going to write it down. 1 over 512 is going to be 0.5 0.01953. That's kind of enough. Okay. Now I'm going to type the function into my calculator. That's going to be y equals, let me clear that, 8 times, parenthesis, 1, divided by 2, parenthesis back, raised to a power of x minus 1. And I'm going to do the same, second graph. I'm going to get in the table. Now I'm going to look for this decimal that I got. So like I said, if you can change the fraction, change into a fraction, then you don't have to convert this answer that we need. Otherwise, change into a decimal, since your calculator might only be able to give you the decimals. So I'm going to go down and keep going down, still not seeing it until I see, there you go, 0.00195. And that's the number that we need, because if we go down again, that's going to be a different number. So clearly this is the number we need. And for that number, it is n equals 13, which means a sub 13 is actually 1 over 512. There you go. That is the process of using our calculator to help us find the value that we need. Okay. Now, since there are only 2 examples like this, but it's kind of a little process, I'm going to ask you to do it more practice. So you can pause here and try these 2 questions, go through the same kind of process. Question B is similar to something that we have learned in the previous lesson. Question A is basically the previous 2 examples. Hopefully you have tried. Here are the answers. And that is everything for this lesson. Thank you.